So next presentation from our partners at Spectron. It is Genette Alcaraz and Ranalli. So Genette is the CEO of the company. She has extensive experience with different projects and basically driving the business forward, making the relationship with partnership and with different companies, and she excels at it. Liz is the sales director at Spectron, and she previously worked at Oxford for atomic force spectroscopy division. She has 2 decades of experience in scientific instrumentation and consumables, and lives values building strong partnership and supporting the scientific community she serves. With that, please. Was I close? Okay. All right.
Good morning, everybody. Thanks, Sergey and TSP, for having us. I do want to preface that he asked us to do this talk before he told us it was at 7 a.m. So, forgive us. So this is our innovative take on, cone cleaning from a manufacturer perspective. So when to maintain, refurbish, replace cones, and kind of reduce your operating costs, which is always the push for labs these days. So more about Spectron. Spectron was founded in 1998 by our founder, William Faulkner. He brags that he was the owner of the second variant ICP in the US. And he basically founded Spectron in order to make his own cones. He just basically was like, the market's too expensive and I'm gonna make my own cones. And 28 years later, we're still here doing that, selling over 40,000 cones into the market, serving the world's largest ICP manufacturers and OEMs, and doing that here, all made in the USA. And we're located in Ventura, California. So this is a practical manufacturer-led perspective. Interface cones are critical to the ICP performance and operating costs. Their maintenance decisions directly impact sensitivity, stability, and downtime. This talk focuses on when to maintain, refurbish, and replace the cones. Spectron shipped over 40,000 cones last year, so we have a lot of experience in handling cones, and a lot of this talk goes to voice of customer, what the customers are asking for, what they're telling us, the calls we get when cones are dropped in the labs, or come back to us really damaged for refurbishing or recycling. So something to know about Spectron is our cones go through a multi-phase quality control process. So I'm going to let you see a little bit behind the scenes. So here's some of our best-in-class quality that's verified. So these cones go through, and this is true for both new cones and refurbished cones that Liz is going to talk about shortly. So these cones go through a multi-phase process. We have certificates of conformance for your materials when looking at things like carbon, boron, silicon, and making sure these materials ensure the optimal performance in your instrumentation. We look at things like angles, tip height, and all the things that optimize performance in the ICP instruments as defined by the OEM drawings. So as you know, the cones drive performance, but also the cost. The cone geometry controls ion transmission efficiency, our surface condition affects signal stability and background, and premature replacement increases operating costs unnecessarily. So performance degradation is often gradual and easily overlooked. So what we did was create kind of a decision tree and product that helps customers in the market with some of the trends that we're seeing. So some of the trends that we're seeing, I've been at Spectron for almost 11 years, and some of the trends that we're seeing and hearing about are that a lot of the large labs have less technical employees, and they receive less training now. So when I first started, I think everybody I talked to had at some point used an ICP in their undergrad or graduate degree and had prior experience and was a really robust user at some point. And that's just not the voice of customer that we're hearing today. So we're kind of educating users on a lot of the cone care and cone maintenance. And then labs are just lacking time and resources for troubleshooting issues, and that can lead to premature retirement of cones, which is a huge cost for these labs. And then it's important to note that cones are inherently just a simple item. They're a metal machine part with a hole in the middle, and so there's no electronics there. So if you're seeing performance issues, it's typically related to cone wear or cone condition. So we came up with, it looks very complicated, I know, but we came up with this maintenance decision tree on how to help lab users make consistent decisions for cone care. So basically, you're going to look at a performance issue, and you're going to decide, okay, is this cone a candidate for cleaning? Okay. Or is this cone damaged, and what's the process there for either recycling, refurbishing, retirement, or some cleaning methods? So the first thing you would do is check for damage. On the left, you would see cones that would not be eligible for cone cleaning because they have orifice damage. You would check this under a 10x reticle. And in that case, these cones are refurbishable. You could send these back to Spectron, and these could be made 100% good for a very small fee. And you could get these back into your lab within a couple weeks. And so that would be something that you would not want to retire if these are platinum cones. So it's important to start with maintenance as the most effective step if the cone is not damaged. And that would avoid unnecessary removal and cleaning. And then we're going to track performance trends before intervening. So we get a lot of users who just swap the cone because it's the easiest thing to do. And then we get a lot of cones back to us that look perfectly good. They're completely in spec. And so it's just it's a cost savings for the labs to be better educated. And platinum cones are really robust and can resist a lot of buildup. So in terms of making purchasing decisions, it's important to note that those are the best options for longer use. So if a cone is a candidate for cleaning, you're going to have to decide on a gentle or more enhanced cleaning, and that's going to be based on kind of the buildup on the cone. The gentle cleaning will remove some deposits without altering the geometry. Just be careful that overcleaning shortens the life of the cone, and those options would include refractories that would come off with DI water and mild citronox or soaps and detergents. Obviously, an enhanced cleaning is going to be for really caked on refractories. We'll show you some pictures of those shortly. And those would be more with nitric acid. And that nitric acid, you want to be careful. It depends on the type of cone. We've seen a copper cone completely get eaten through before, so you want to be careful on the percentage of acid based on the cone material. And if you're not sure, you could always check with us. Because we have customers who use platinum nickel cones and they think or nickel cones that think they're platinum nickel cones. And it's important to note that handling matters. So a lot of the feedback that we get is that there isn't a product out there yet that really helps for optimal cone cleaning. It's all single cone use cleaning. You're using a ton of liquids because you're filling up large beakers. You're often saturating the entire cone into a material like an acid, so you're damaging threads, you're eating through your nickel or copper, and you're sometimes having to put the cone tip down or tip up and then saturating it completely. So what we did was come up with a product, and we have a sample if anybody wants to see it at our booth or here. And this is kind of the future of cone care. And the goal here was to answer all of the questions that we've heard in the market in terms of how to optimize cone cleaning across consistently across labs. This here that we're picturing is the Agilent version. And then we also have a PerkinElmer version so far, but I'll go back a little bit. So basically the goal here is to have a cone cleaning kit where you have a reservoir which you can put in the nitric acid, at which point you'll see only the tip being saturated in the acid, and it protects the rest of the cone base, it protects the cone threads. And then there's an option where there's a hole through the middle of some of them, and that allows for complete cleaning if you're doing something like a citronox, alkanox, or detergent. And so here's the PerkinElmer version. This is for the Nexion set of cones. And then, so the goal of this is to set that inside a sonicator. If you're just doing some nitric acid, you could also just set it on your desktop, but you could also put the whole thing inside your sonicator and clean it that way, which is ultimately the goal. This was designed specifically for each manufacturer's cones, so it's specific for each cone set. It holds them securely to prevent handling and damage because it was designed for each cone footprint. It's going to isolate that cone tip, as I said, to eliminate that exposure on the bases to those acids. It's going to create a seal, so using the gasket, we're creating a seal in the sonicator so that liquids aren't cross-mixing and it's staying localized to the cone tip. It's going to allow for less waste and less spilling, and it's going to ensure for these labs repeatable cleaning conditions to all lab users. So we are also giving away a free one of these, like our founder, Bill Faulkner. We're going to give away the first and second free cone kits into the market for anybody who stops by our booth and gets scanned or gives their cards. And I will pass it on to Liz.
So Genette spoke about cone cleaning and the new cone cleaning fixture, which will support you in the lab, but we'll now move into talking about when cleaning is not enough. So science cleaning alone will not restore performance when maintenance is no longer enough. So you'll continue to see after your routine cleanings in either the gentle or enhanced method that Genette spoke about, tuning instability. You'll still see visible orifice damage or embedded deposits, which cleaning, even in the enhanced method, will not rectify. Persistent sensitivity loss after your cleanings, and increased background noise. In the visuals here that you see oxide and salt buildup, pitting, erosion, or discoloration near your orifice, and collapse from mechanical stress. These would be indicators that your cleaning, gentle or enhanced, you need to further review and consider moving into replacement if they're nickel cones or refurbishing if they're platinum cones. So when is it time to refurbish or recycle? We just spoke about that a little bit, but damage caused by mechanical impacts, drops, or handling. Genette touched on that a little bit earlier. When we're cleaning, especially in an environment without a cone cleaning fixture, there can be lots of handling issues or impacts on the cone tip if they're dropped. If you have partial or full orifice occlusion, this also would be an indicator to consider refurbishment if it's a platinum cone. Bringing your platinum cones back to life. These visuals are actually really incredible. So you'll see in the before image, your analytical zone and the base can be refractory buildup and look really nasty, right? And in those after visuals, you'll see that after sending it back to Spectron, the condition the cone will return to. So not only does it return into manufacturer specifications for the orifice, but it returns to pretty beautiful, like it once looked when you first received it. So refurbishing is saving you money and saving the planet, right? We are doing precise removal of refractory material. So you'll see the before of the flared tips on the left, and then the restoration of the cone tip on the right. Refurbishing can be really beneficial for mechanical impact when dropped cones or heavy deposits. Here are some more machining magic visuals for you. You'll see the full orifice occlusion and after refurbishment on the bottom, how that cone looks. And that cone will perform just like it performed when you opened it out of the box new. It's in manufacturer specifications. Oftentimes, the assumption in the market is a refurbished cone is a used cone, which may not even be your cone. And refurbishing is always done on your cone for platinum. Precision restoration and not just cosmetic repair. So it's removal of refractory material, precision reshaping of the cone orifice, and restoration to original manufacturer specifications. We talked about our best in quality, and that also goes into our refurbishing. So we have our pre-inspection, our inspection during process, and then our final inspection. So some of those inspections that we do are flange thickness, tip height, counterbore depth, orifice ID, threads, material. So all of those take a part in each step of the inspection process during that initial pre-inspection to even see if the cone is refurbishable or not. And then after refurbishment, because we do not want to send a cone back to any of the users that's not in manufacturer specifications, because that would not be optimal for you in the lab. So if your cone is unable to be refurbished due to it being a nickel cone or a platinum cone that needs to consider retirement, when refurbishment is no longer viable, severe orifice collapse or cracking, the material is annealed, or insufficient material to restore cone geometry. We can't add platinum material to the platinum cones. We can only work with what's there. Or you may have damaged threads or tool holes, which would need to be retired. Sustainable replacement decisions. After your cone cannot be refurbished or your nickel cone needs to be retired, you have responsible end-of-life management decisions you can make. So retired platinum cones can be reclaimed. We can support a circular economy and put that material back into production, and that comes with material credits from the reclaim and offsetting your future purchases. So we actually will cut out the platinum, put it back into rotation, so we're supporting that circular economy and give you money back for that retired material. Retired nickel cones can be recycled. So often we hear from users that they have drawers and drawers of nickel cones, right? I'm sure you guys can all relate to that. And we can take care of that and make sure that we're recycling those responsibly and getting those out of the labs and freeing up your drawers. And then also supporting sustainability actions in your lab. Most of us are being pushed for lower carbon footprints and coming up with sustainable actions for our lab, and this is a great one. We offer sustainability certs for people that recycle with us so that you can check that box as well. And you'll see a visual here of just some of the recycled cones that customers have sent back to us for recycling. So some of the things that we discussed during this talk is always start with maintenance to preserve cone geometry. Less is more. Create consistent process for troubleshooting and minimal downtime. Use the cone cleaning fixture to support cleaning efforts and reduce unnecessary damage and cone life reduction. Refurbish platinum cones when cleaning is no longer sufficient, and replace only when geometry of platinum cones and material integrity are compromised. Informed decisions reduce operating costs and save labs money. Extending the cone life, optimizing performance requires a combination of well-informed maintenance decisions. Thank you so much. Are there any questions?